All right, let's get right to it. I am your resident Cambridge exam turnaround coach, and today we're doing a complete grade makeover audit for probability and statistics too. Look, if you've been grinding through past papers, you already know that continuous random variables, probability density functions, calculating mean, getting variance from a PDF, honestly, it can feel like a total maze. But what if I told you the examiners actually have a specific, hidden playbook, a precise rubric they use to award or mercilessly deduct your marks? Well, today in this explainer, we are going to crack that exact playbook wide open.
15%. Let that sink in for a second. This single topic right here, continuous random variables and PDFs, accounts for approximately 15% of your total marks in Paper 2. That is a massive, massive chunk of your overall grade, resting entirely on just one section of the syllabus. You literally cannot afford to leave these points on the table, especially if you're gunning for those top-tier A-star marks.
So, you've got to ask yourself, if this topic is heavily weighted and everyone knows it's coming, why do students consistently lose these crucial marks year after year? You might be thinking, well, the integration is just too hard, or the algebra gets way too complex. But actually, scratch that. The principal examiner reports reveal something completely different. The biggest hurdle isn't always the math itself. The real trap is evaluating the evidence and drawing the correct, logically sound conclusions. It's really all about the argument you're building with your numbers.
Okay, here's our roadmap for today's audit. 1. Decoding objectives. 2. The method mark strategy. 3. The 5-step framework. 4. Top 3 warnings. And 5. The final loop.
Let's jump into Section 1, Decoding Objectives, what examiners actually want. Look, this comparison right here brilliantly illustrates the core academic benchmark you're up against. Examiners are heavily prioritizing logical, structured reasoning and deep analytical connections over just superficially skimming across a wide range of topics. I see it all the time. Students just memorize a handful of integration formulas, cross their fingers, and hope for the best. But that's just relying on superficial breadth. The assessment framework actually demands analytical depth. They want to see that you fundamentally understand a theoretical architecture behind continuous random variables and exactly how the whole shebang links together.
To really crush this, you must demonstrate knowledge, application, and analysis. But here is the secret sauce. The principal examiner reports consistently show that candidates who explicitly reference cross-topic connections achieve significantly higher marks across the board. Meaning, you have to recognize when a PDF problem connects to concepts you've learned completely elsewhere in the syllabus. It's like a giant puzzle. You aren't just doing math in a vacuum, you're proving to the examiner that you understand the entire mathematical ecosystem.
Which brings us to Section 2, the method mark strategy, proving the process.
The method mark strategy is a core assessment principle, and honestly, it's an absolute game changer. Marks are awarded for demonstrating the correct procedural steps and mathematical methodology, rather than just spitting out the final numerical answer. To pull off a grade turnaround here, you need to radically shift your mindset. You've got to stop merely hunting for the final number. Think about it. If you make some tiny, silly arithmetic error on the very last line, but your methodology leading up to it is absolutely flawless, you can still capture the vast majority of the marks. But if you just confidently write down a final answer with 0 workings shown, you get nothing, 0. You have to rigorously prove your mathematical process right there on the paper.
Let's move to Section 3, the 5-step framework, executing the problem.
Quick timeout. If you want to stop serving up average grades and unlock the secret recipe for an A-star, hit subscribe to AC Exams right now and turn on that notification bell. We do these deep dives all the time. Okay, back to the audit. By systematically following these 5 steps, you ensure absolutely no method marks are left on the table. First, deconstruct the question. What exactly are they asking you to find? Second, extract the relevant data from the text and tables. Third, select your analytical framework. Like, are you integrating to find a probability, or are you setting an integral equal to 1 to solve for a missing constant? Fourth, execute with crystal clear notation. And fifth, present your findings with the correct terminology using proper headings. I know it sounds super simple, but trust me, under the pressure of a ticking exam clock, candidates skip these exact steps and just bleed marks.
All right, Section 4, top 3 warnings, the pitfalls to avoid.
Listen to this. This is a massive red flag straight from the principal examiner report. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. Guys, before you even write your first equation in an extended mathematical response, you must clearly define your terms. If you mix up your terminology when discussing the mean versus the variance, or if you use the wrong symbols for your probability density function, you are basically throwing away vital structural marks before you've even done a single calculation.
So I need you to make a mental note of these top 3 mistakes. Number 1, using the wrong mathematical approach for the context. Number 2, forgetting to check your format and presentation, because yes, clear annotation and proper headings are strict Cambridge conventions. And number 3 is the absolute classic trap, providing generic answers that don't directly address the specific context of the continuous random variable problems sitting right in front of you. Whenever you draw an evidence-based conclusion, you have to tie it back to the exact scenario described in the prompt. Generic doesn't cut it.
Which perfectly sets up Section 5, the final loop, closing the argument. Your absolute final step is to run this analytical loop. You've already identified the information. You've logically solved the math. Now, you evaluate. You've got to identify any assumptions you made along the way. Evaluate the limitations of your data. And most importantly, check if your answer is actually reasonable. Think about it. If you just integrated a PDF and calculated a probability of, say, 1.5, well, probabilities can't be greater than 1. Your evaluation step should catch that instantly. And when the question asks for it, make justified recommendations or comparative analyses, supporting every single claim with the hard evidence you just calculated.
So, as we wrap up this explainer, I have a question for you. Will you rely on just the final answer and hope for the best, or will you actually prove the process? As you sit down for your next paper to practice, force yourself to apply this method-mark strategy and run that deconstruct, solve, evaluate loop. It is the guaranteed way to capture every single available mark. Oh, and before you go, make sure to subscribe to Ace the Exams, turn on those notifications, and drop a comment below telling me which specific math topic you find the absolute hardest to crack. Keep practicing, keep proving your process, and I'll catch you in the next explainer.